Hi there, folks. In this lesson, we're looking at kind of some of the special linear functions that we've been dealing with, and there's two of these that we've looked at. The first of which is direct variation. Remember, direct variation is this y equals kx, where k is the constant of variation. And really, this is a special type of y equals mx plus b. It's a line that goes through 0, 0. And instead of calling the slope, or m the slope, we call it k, and it's called the constant of variation. And that's because these have very special properties. When the line goes through 0, 0, it makes the x's and the y values for each ordered pair kind of proportional in a sense, because each of them would give us the slope when we do one divided by the other. So again, direct variation is just a special line, goes through 0, 0. For example, when we look at something like this guy, this is direct variation. And so it's in that form y equals kx. Again, k still acts just like the slope because it still is the slope. It just gets a special name because this is a special kind of linear equation. All right. So this one is direct variation. It goes through 0, 0. So the y-intercept is 0. And then it has a slope of -2. So down 2 over 1, down 2 over 1, or up to back 1. And I could keep that pattern going. And I graph my line, and that's it. Okay, that is direct variation. It's a line that goes through 0, 0. Okay, it goes through the origin. If we look at the next one, same kind of thing. We can tell this is direct variation because one, it's in that format y equals kx. But two, even if you think about it in terms of like y equals mx plus b, it's like a plus 0 here. That's why we don't see anything. Okay, and so it's a special line that goes through 0, 0. So this one goes through 0, 0. So we're going to start at the origin. And then we're going to use that k value this time as the slope. Again, the k value is still the slope. It just has a special name, the constant of variation. So up 1 over 4, or down 1 back 4. And I draw my line. Okay. So now here's the thing that's really special about direct variation, and this is why it's called the constant of variation, all that stuff. In direct variation, the x and the y values are proportional. In other words, if I go to any ordered pair on this thing, if I take one ordered pair and do the y value over the x value, it equals any other ordered pair where I do the y value over the x value, okay? So here, the idea is like y1 over x1 equals y2 over x2, okay? So any ordered pair is proportional to any other ordered pair, and really each of these, when you look at something like this guy, these are actually all giving us the k value or the slope, okay? So this is what the k value is. It's just a y value divided by the x value. And again, that's also the slope. It's really just this special thing that happens when we talk about direct variation because it's going through 0, 0. Any y value minus 0 is just still that same y value. And any x value minus 0 is still that same x value. So the slope just becomes any y value divided by any x value. And that's true for every ordered pair. So we have this idea of proportionality between the ordered pairs, okay? Here's how we kind of use that. Right here it says, suppose y varies directly with x. That is a fancy way of saying this is direct variation. So when you see that suppose y varies directly with x, that is us saying this is direct variation, all right? So now we know the x and the y values are proportional. It says when x is 5, y is 12. Find y when x is 8. And so again, we just set this up as a proportion. We say, okay, I'm going to take that first x and y values. It's a y over x. Well, that's going to equal any other y divided by any other x. And so the second ordered pair here says find y, so I don't know y, when x is 8, okay? So that first ordered pair, that 5, 12 becomes 12 divided by 5. The second ordered pair, 8 comma y, because I don't know what it is yet, becomes y over 8. And now I just cross multiply and solve. So here, 5y equals, that's going to be a 96. And now I divide each side by 5. I'm just going to leave this as an improper fraction. We say y equals 96/5. Okay. The second special linear graph that we have is absolute value. And absolute values, remember, the ones that look like V's. So they almost have two slopes and things like that. We have this vertex where the two lines come together, and then it goes off in the shape of a V from there. Okay. When we graph this thing, the general format for this is y equals a times the absolute value of x minus h plus k, where the vertex, that point where the two lines meet, that's the tip of our V. It's the highest or lowest point on the graph. That's defined by HK. And notice right here, this This negative sign that's in here means we do the opposite of that. So the opposite of this guy would be H. But then this guy is already a positive K, and we just leave it as positive K, okay? So remember, in this one, because that minus sign is built in there, we do the opposite of the thing with the X, and that gives us the X value for the vertex. We take the thing on the outside exactly the way it is. We don't change it at all, okay? And then the other thing, this value out front kind of gives us the rest of the graph. So that HK is just the vertex. That's where we're going to start. And then this value out front right here, that tells us everything else, okay? That tells us whether the V opens up or down, whether it's a normal V or an upside down V. It also tells us the shape of this thing by acting kind of like the slope, okay? So that A value, when that A value is positive, it opens up. When it's negative, it opens down. And then we use that A value kind of like slope, all right, in order to graph this V. For example, if I look at something like this guy, again, I want to find the vertex. So I start by finding the vertex. And the vertex on this one, remember, I do the opposite of this guy. That's a positive 1. But then this guy, I take it exactly the way it's written. That's a positive 3. So my vertex is 1, 3. Then I look at the A value right here, this value out front. Because that's positive, this is going to open up. So I'm going to state that the graph is going to open up. And then my slope, essentially, again, it's not exactly the slope, but we'll treat it kind of like slope, is whatever that A value happens to be. It's the 3/4. We just have to ensure that the V, that we're graphing a V, first of all, and that it opens up using that 3/4. So here's how we do that. I plot that 1, 3. And then I want to open up with a slope of 3/4, which means I go up 3 over 4. But I do that in each direction in order to kind of form this V, and that's it. Okay? And notice when you actually technically look at the slope of each of these lines, like the slope of this one is 3/4, but the slope of this one is actually negative 3/4. And that's why that A value is not exactly slope. It's kind of a generalized version of slope because every one of these V's is always going to have the positive and the negative version of slope, okay? That's how we form the V, all right? If I look at this one, same kind of thing. Again, I take the opposite of the guy that's written right here. So for the vertex, that's a negative 4. But then again, the value that's written here, that is the Y value without changing it at all. So that's a positive 1. And now I look at the A value. The A value here is negative this time. So this thing is going to open down. And then I'm going to kind of use that A value almost like slope. Okay. Again, that's not exactly slope. I guess I can call it negative 2. Okay. It's not exactly slope. The two pieces of the V will have a slope of positive 2 and negative 2. But generally, it's kind of like the slope, and we'll treat it that way. So here, negative 1, 4. So negative 1, 4 is right here. This one's going to open down with a slope of 2. Well, that's like going down 2 over 1. But I have to do that in each direction in order to create a V. And really, that's using a slope of positive 2 and negative 2, but I'm just ensuring that the V opens down. I'm using that kind of like slope in order to get the shape of this graph. And that's it. I draw my V and I'm done. Okay?